we're given a geometric sequence that we have to calculate or find the value of the ninth term. Now, this given sequence, this given geometric sequence is especially interesting to me because there are two ways to do it. One, you can use your exponential laws to find the constant ratio, or you can just use the method that we've been using to find the constant ratio. I will start with the exponential way and then do the conventional way to determine the constant ratio. So if you look closer, you can see that all these numbers can be turned to exponents to the base of 2 that have a base of 2, because essentially this is 2 to the power 5, this is 2 to the power 6, and therefore this is 2 to the power 7, and so on and so on, right? So to determine the constant ratio, we have to use this formula. T3 over T2 must be equal to T2 over T1, and this implies that T3 must be equal to T2, and by the same vein T2 over T1, like, they must be equal. The quotients of these terms must be equal. So using T3, what's T3? T3 is 2 to the power 5 over 2 to the power 6. It must be equal to 2 to the power 6 over 2 to the power 7. According to one exponential, or the quotient exponential rule, it states that when you have two bases, you can just minus the exponents. So we have the same base 2, then we're just gonna minus the exponents. Likewise on the other side, I'm gonna do that. And this would imply that r is equal to 2 to the power negative 1, or otherwise a half. So r would be equal to a half. Then we would do our normal routine to determine the general term. So Tn is equal to ARn minus 1. A is 2 to the power 7, as we've determined here, and r is 2 to the power negative 1, as we've determined here, and then it's n minus 1. So we're just going to expand this. 2 to the power 7 multiplied by 2 to the power negative n plus 1 is going to be equal to 2. If you have the same basis, you add n as a multiplication, you add the exponents. So 7 plus 1 is 8 minus n. So this would be your general term, but we're told to determine the ninth term. So we're supposed to determine T9, and that's essentially 2 to the power 8 minus 9, which is 2 to the power minus 1, which is the same as the constant ratio, which is a half. Another way of doing this, said I'll show you two examples, two methods. You have this 128, 64, 32, ... and you just take the constant ratio, T2 over T1 equals T3 over T2, and this essentially means 64 over 128 must be equal to 32 over 64, and this is indeed a half, and this is also a half, so this implies that r equals a half. And then just this was just another way of determining the constant ratio. I've already shown you on this paper that, you know, as you go forward with the steps, you're just gonna get to the same answer. So it was just an interesting thing that I thought you should just see how you can turn these terms into basis of 2 and essentially just work with exponents. Okay, so that's it for this lesson. I guess I'll just see you in the next lesson. Thank you.